Good morning again. So this is 419 Computable General Equilibrium Models. This is our 7th lecture and the last lecture before the midterm. We're going to continue with the model in chapter 3 in your textbook. So let me share my screen now. Okay. So let me minimize this. All right. So the last time when we were talking about this model, we defined several things. So let me once again catch up with there. So first, one thing we have already defined was this, right? So we defined something we call the price of value added, right? The price of value added depends on factor prices times the V matrix, right? Plus P times A. So this must be equal to P star. Now, if you realize that this symbol star means equilibrium. All right? Now remember the meaning of this equation. So on the left-hand side here, you see the average cost, right? So average cost has basically two components. One component, the thing on the right here, P star A, is originating from where? Originating from the intermediate input demand of the firm, right? So this A matrix is the matrix of technical coefficients. So they determine how much I'm going to use as firm J from the goods good I, okay, for each I and J, obviously. And then I pay a price for these intermediate inputs. Plus, I also pay some price for the primary factors. Remember, factor price. So if you want to be more explicit, so of course you have P1 star dot 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 Pn star, right? And for omega, you have omega 1 star dot 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 omega k star. Okay, so for each factor I'm paying a price. So this becomes the price of value added, and this matrix, remember, it is a diagonal matrix, right? So this gives me the technical coefficient concerning the conversion of value added to output. Okay, Vn, right? So this condition is the zero profit condition. Okay, and if you remember, so this is, let's look at the dimensions again. This is 1 by n. This was a row vector. This is also a row vector. So this is a square matrix. Okay, this is once again a row vector, and this is again a square matrix. All right, so dimensions should match. Okay, and obviously again, P star and omega star here are unknowns, right? P star and omega star are unknowns. So that was the first set of equations we have already recovered. Now next, we have this. So there is this total demand, right, originating from where? So total demand for these commodities, okay, will originate from two sources. One is consumption demand, okay, and the other is, let me now create some space here. Consumption demand is by households, right? For each good, there is this consumption demand, plus there is intermediate input demand, right? So consumption, this is consumption demand. By households. And this is intermediate input demand by firms, right? Now, here I define a new vector, Y star, right? So Y star is something like that. Y star is basically this. Y1 star, Y2 star, dot, 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 Yn star. So what is these Ys? So these are the total production levels, right? Total production levels. Now, if you multiply this vector with Aij, the A matrix, so this is A, right? A is A11, A12, dot, 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 A1n, A21, A22, A2n, AN1, AN2, ANN. Okay? And once again, Y star is Y1 star, Y2 star, dot, 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 Yn star. Now, what happens when you multiply? So this is, again, you should be careful with the dimension. This is n by n, and this is n by 1, right? So if you multiply A by Y star, what do you have? So first, you take the first row, right? You take the first row in matrix A and multiply it with the first column, right? So you have something like this in the first element, right? So at the end, of course, you realize that this must be a column vector, right? Because n by n multiplied by m by 1, it becomes m by 1. So it's a column vector. So in the first row of this column vector, you have what? You have A11 times Y1 star plus A12 times Y2 star, right? A13 times Y3 star. Then finally, A1n times Yn star. Okay? Then you take the second row and multiply it with the first column again. So you have A21 Y1 star, right? A22 Y2 star, A23 Y3 star, and A2n finally Yn star. So if you realize, the first row is the total intermediate demand for the first good, right? Right? So remember, Aij, Yj, that was the thing that we look at, right? So if you look at these indices, right? So this is equal to Yij. All right? So in the first row, we have the intermediate input demand for the first good. In the second row, we have the intermediate input demand for the second good, and that goes on. All right? So if I go back to here, so that part is that. Okay, so this is n by 1. And then this must be also n by 1 by construct, right? And because this is an addition. And consumption demand, of course, originates from the consumer's problem, right? Each consumer faces some prices, some product prices or output prices, and some factor prices. They sell their primary factors in the factor markets. They obtain some income, and then they spend this income to the consumption goods. All right. Now, in equilibrium, obviously, in equilibrium, this must be equal to that, right? Total supply must be equal to total demand. This is the market clearing. Okay, this is market clearing for the produced goods in the economy. Okay. Now, finally, we have the factor markets, right? And there we have this. So this part is demand, and this part is supply. Remember, the consumer decision gives us the supply levels, right? Because there is this utility maximization problem, right? So there is this constraint. Right? Remember this? This was the constraint. So once you solve it, you find the personal use by the consumer, and then you look at this. Okay, so this becomes the supply. So supply comes from the consumer problem. Demand, remember we discussed last week, comes from the firm's problem. Right? And here, obviously, consumer problem, the supply of factors. So this is primary factors. Okay. X1, X2, dot, 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 Xk. Right? So supply comes from supply depends on only the prices. Why? Because endowments are exogenous. Right? Endowments are exogenously given to the consumers. Now, demand side depends on how much firms would like to produce, right? Because remember, let me just remind you this thing. So this is equal to Z omega Y is equal to B omega Vy, right? Remember what B omega was. So this is N by 1. Right, this is M by 1. This is M by N. And this is K by N, right? Because you have K factors. So this was the optimal use of factor K for the production of good I once the firms take optimal decisions, right? In terms of cost minimization. All right. So this whole thing then is K by 1. And again, supply must be also equal to K by 1 because you have K different factors. Okay. So then what do we have at the very end? So we have first a system of equations like this, right? Okay. Once again, the first one here is the market clearing conditions for the produced goods. Okay, market clearing conditions for the produced goods. Total supply is equal to total demand. The second one is the market clearing conditions. There are more than one of them, obviously. Market clearing conditions for the primary factors, land, labor, capital, other stuff, right? So this is demand by firms, and this is supply by households. And finally, so here basically the unknowns are P star, right? So in these markets, the prices you're gonna find P star. But careful, this is a general equilibrium model. Those prices will depend on product factor prices as well. Okay. Now here, the prices you are searching for are factor prices because these are the factor markets. But once again, this is a general equilibrium model. So they depend on product prices as well. Okay. And finally, this part in a general equilibrium model tells you the scale of the firms. In each industry, there is a firm, and how much this firm should produce is an equilibrium concept. It depends on equilibrium. So Y star is an endogenous variable. Okay. So if you look at these markets, if you look at these markets in isolation, you see a picture, but they must all depend on each other. Why? Because this is the general equilibrium model. Exactly because this is a general equilibrium model, right? So we cannot solve these unknowns separately. Instead, we look at the entire system. Okay, we look at the entire system and we get the prices simultaneously. That is the idea. Because imagine, look at the first equation. I mean, first set of equations. If I gave you some value for omega star and some value for Y star, then from the first equation, you would get P star, right? Similarly, if I give you, for instance, P star and Y star, equation 2 would give you omega star. Okay, you see that? So that's the notion that we are after. We need all three sets of equations to solve for our unknowns. All right. So now let's count them. So if you look at this system, how many equations you have? How many equations are there in this system? Orada mısınız?
It looks like 3, but
it is not 3.
Wrong.
It's not 3. That's obvious because these are all vectors. Right? So how do you understand how many equations? Well, you're going to look at the sizes of these vectors. Right? Look at the first equation. So what's the size of Y star? Huh?
Okay.
No, Y star. So how many goods do you have in this economy? How many produced goods do you have in this economy? N. So you have N equations here, right? You have N equations here. Because for each good, I just showed you. For each good, where's that? Here, for instance. For each good, you have an output level, right? So you have N equations in that first set. How many here in the second set? How many equations in the second set? Remember the meaning of this equation. This is supply equals demand for primary factors, production factors. So it must be
K.
K equations, because you have K different primary factors. And what about the last one?
N.
N. Why? Because here you have 1 by n different prices, right? And you have n different average product, average cost levels. Okay, so you have n equations here. So in total, you have 2n plus k equations. Okay, and then of course you ask, okay, how many unknowns? So how many unknowns we have?
3.
No. Again, we have P1 star, P2 star, dot, 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 Pn star,
Yeah.
right? So we have n different price levels, okay? And then we have k different factor prices and n different product levels, output levels, okay? So same number of equations, same number of unknowns, you have a square system. Okay? Now, how do you solve it? You must be careful with the Walras law, right? Can somebody explain how to proceed from there? So you have 2n plus k unknowns and 2n plus k equations. So these equations are coming from market clearing conditions and the zero profit condition for the firms that basically pin down the output levels. And your unknowns are output levels, prices, and factor prices. So product prices and factor prices. So how do we proceed from here? What to do next?
2n plus k minus 1 equations must satisfy the equilibrium, I guess.
So yes, what's the reason behind it? Explain that to us.
It is enough, according to Walras law.
Okay, so Walras law tells you that if you clear all markets but leave just one market, right? That last market must also be in equilibrium, right? So Walras law tells me that one of these market clearing equations is actually redundant. Okay, the same information about prices is already embedded in the other n minus 1 equations, right? Or k minus 1 equations. So from the first or the second set, I must exclude one of the equations, one of the market clearing equations, because that market will be already cleared according to the Walras law. All right, but then I have one equation missing. Okay, so how to find this equation? Because again, I have unknowns, right? What do I do in such a case? Bunları size anlattık gençler. What do I do in such a case? Now, okay, because of the Walras law, I excluded one of the equations because it is redundant. But I should do something else to proceed.
Price normalization.
Exactly. So I have to impose some sort of a price normalization, right? Either I'm gonna do that. For instance, I'm gonna do something like, let's say this, or I'm gonna do something like this. All right, I will introduce a new equation, Careful here. All of these are equations, right? Then again, I have 2n plus k equations and 2n plus k unknowns. Okay? So that's something we do in general equilibrium models because of the Walras law. Okay? Now, there is also a practical concern. And the practical concern is about the curse of dimensionality. Okay, the curse of dimensionality. Because we saw these models in computers, as I discussed before. Okay. Okay. Now, the dimension of this system is 2n plus k. And at some point, we have to deal with some matrix inverses. Okay. So computers are very good at doing such stuff. But if your dimension is going up and up, if your dimension is getting larger and larger, then computer needs a lot of time to do these calculations. All right. So for this reason, we do something else here. We do some reduction. Okay. We want to reduce this dimension to a lower number. Okay. So how do we do that? Look at these equations. We can do some variable eliminations here if you look at this carefully. Okay. If you look at this carefully, you can do some variable reductions. Okay, eliminations. How can I do that? Now, first of all, look at the first equation. So this is again a matrix equation. So this is, don't forget this. Here n by 1, here k by 1, here 1 by n. Okay? We have these dimensions. So in the first equation, I can do this. I can write this as CD okay. So what do you see here? Well, it turns out that under certain conditions, I can write y star as a function of p star and omega star. Okay. How do I do that? Well, first I should realize that y star could actually be written as in y star. So what is in here? In is the identity matrix. Okay. In is the identity matrix. Identity matrix is something like this. Okay, so the diagonal elements are all equal to 1, and of the diagonal elements are all equal to 0. Okay, so if you multiply any vector or matrix by this, so this is of course m by n, this is m by 1, you're gonna get the same result. So if you multiply it by some matrix, okay, you're gonna get the same matrix. Okay, n by n by m. You're gonna have n by m. All right. So that's the identity matrix. Now, if I do that, so I have what? I have CD P star omega star y star a y star, and then I have in y star a y star, and then careful, I can write this. Okay, now how do I do that? Because this is n by n, this is also n by n, right? And this is n by 1. All right, so I have now in minus a y star equals CD P star omega star. Okay, and what I want to do here is to find y star is a function of P star and omega star, right? Because then I can eliminate y star from the system, right? That was my purpose. My purpose is to eliminate some of the variables and some of the equations so that I decrease the dimension of my system, right? So I leave it here, and I'm going to continue after the break. Now, if you have questions, I can answer them, but I'm going to continue exactly from here. Again, my purpose is to reduce the dimension of the system. So I want to express some of the variables in terms of others, so I can eliminate these from the system, and I'm going to reduce the dimension of the system. So the computer will be solving the system much faster. Okay, so time is around 9:40. Let's meet at 9:55. Okay. At 9:55, we're gonna continue. Just look at the system before you go to break. Okay, look at the system, and there are a couple of things we're gonna do. Just realize how do we do this? How do we do these reductions? Okay. So I'm seeing you at 9:55.
Okay.
Okay.